So here's the two equations that I want, or excuse me, inequalities that I wanted you to graph. Again, you should not be watching this video if you have not done these two problems yet. So pause it, go back, do the problems, then come here and do them, right? This is some practice to make sure you can do it on your own. The problem on the left is in slope-intercept form. It has a y-intercept of 1, so I'm going to draw a point there. It has a slope of -3, tells me to go down 3, right 1. Is this a dotted line or a solid line? It is a solid line. And I better test 0, 0 to find out if I'm going to shade this side, because 0, 0 is on this side, or this side. So that's 0. -3 times 0 plus 1. That's 0 is greater than or equal to 1. Is that a true statement? Is 0 bigger than 1? No, this is false. So 0, 0 right here is false. So this whole side is false, which means this side is true. And those are my solutions, because shading equals solutions. The one on the right here, I'm going to go ahead and put this in slope-intercept form to graph it. That's y equals 2x plus 6. So my y-intercept is here at 6. My slope is 2, up 2, right 1, takes me off the graph, so I'm going to go the opposite way, down 2, left 1. And is this a, oh, this shouldn't say equals. I'm a terrible person. Terrible person. Let's make this say less than. We're going to make it say less than. It'll say less than on your canvas. I just messed it up here. So, is it a dotted line or a solid line? It is a dotted line. And I'd better test 0, 0 to find out if I switch side to shade. Oops. So this is 0 is less than 6. Is that true or false? That is true. So 0, 0 is true, which means everything on this side of the line is true. And all of this shaded region over here on the left is the solutions for this inequality. All right, if you got those, fantastic. Move on. If you didn't get these right, you need to make a comment to talk to Mr. Dilley, figure something out so you can get those working, because you cannot do the rest of the problems unless you can do this. If you can't do this, everything else you're going to do is wrong. So we need to get this down. So let's look at the system. So there are 3 steps to solving a system of linear inequalities. So what we're going to do is take 2 inequalities, similar to those ones that we just graphed, and we're going to graph them on the same graph. And this is really similar to like what we were doing in the very first section of this chapter. The difference is we're dealing with inequalities, which means that the solution is not just a single point, right? It's not just a single point. This whole chapter, we've been finding that one point where it works, but inequalities have lots of solutions, an infinite number of solutions, which means a system of inequalities is going to have an infinite number of solutions. So we need to find out which of these regions, this one, this one, this one, or this one, has the solutions. So what we're going to do is graph each line. By the way, these are not the lines for these right here, right? This is totally different. Once we've graphed each of those lines, we're going to shade the solutions. So that's exactly what we just did in the previous step. The last thing about systems that's different is the last thing here, which is the region that has overlapping solutions for the individual lines is the solution region, meaning this is where my solutions are for this system. So to use this example over here, let's say this line we had to so this line over here, we shaded the top, and this other line, this one here, we had to shade the bottom. The overlapping area is the area with the solutions. So the area that's overlapping, this has 1, this has 1. But this region up here is the one that has both the red and the green. And because that's the overlapping region, that means that this area is my solution. So we have to graph both lines, do the shading for both lines, and then look for the region that has the overlapping shading. Okay? So let's go ahead and do an example. So we've got a system here. Both of these are lines in slope-intercept form. And we're going to first, number one, we're going to graph both lines. So graphing both lines, I'm going to do the top line first. We're going to call this line 1. And I'm going to do line 1 in red, right? That's going to be the red line. So this is -2 y-intercept. A slope of -1, right? Remember, there's nothing in front of the x, so we assume it's a 1, and because it's negative, it's -1, which tells me to go down 1, right 1. Down 1, right 1. Is this a dotted line or a solid line? It is a dotted line. Now let's do the other one, and we're going to do the other one in, I don't want to do it in blue. Blue's already been used. Let's do green. This is the green line. The y-intercept is 6, 2, 4, 6. The slope is 3. Up 3, right 1 takes me off the graph. I'm going to go down 3, left 1. Dotted or solid? Solid. There's my 2 lines. Step 2, shade the solutions. So we're going to shade the solutions for each of these 2 lines. So I'm going to test 0, 0 for the top one. That's 0 greater than -0 minus 2, so 0 is greater than -2. True statement? True statement. So for the red line, 0, 0 was true. So that means this is true. Therefore, everything on the top of the red line is true. For the green line, we'll test 0, 0. 0 is less than or equal to 3 times 0 plus 6. Therefore, 0 is less than or equal to 6. True statement? Absolutely. So this area is true, which means everything on this side of the green is true. So this section and this section are all true statements. They're all solutions. Remember, shading equals solutions. And then the last thing we're going to do is look for the overlap. Because the overlap is the region where both equations, both inequalities, are solutions. And so it is important to recognize that the only place that will be true for both inequalities is the shaded region. So here, this region in this section right here, that's the area that has both red and green. It's the double shaded region. So that is our solution. The black area here are all the true statements. Those are the areas where there was a double overlap, or excuse me, an overlap that made the solutions. So, graph both of the lines, shade both of the solutions, look for the overlap. The overlap is the solution region. Got some problems for you on your canvas to try this one out. And then once you've got that done, come on back and we'll work on the next video.